Okay guys, this is video number 4. Well, I'm making them kind of short because I had trouble and I don't want to risk them not posting at all. So we'll just do 4 videos. All right, I'm on number 24 now. And again, it's an inverse problem, but it's the first one that we're going to do tangent full out. And I wanted you to get an experience with that. Okay, so let's take a look again with the inverse. So it's alpha minus beta. So we're using the tangent alpha minus beta, but we've got to find our thetas, right? Using the inverse. So let's do that. So we're going to say tangent, okay, and we're going to come up with the angles, and we know they're going to be subtracted. Okay, so you say to yourself, tangent is, sine. Sine is restricted, right, from pi over 2 to negative pi over 2 if you're talking about inverse, so somewhere in here, okay? So that tells you that you're either going to have quadrant 1 or quadrant 4 in finding this. Okay, so where is sine a positive 1/2? Well, sine is a positive 1/2 in quadrant 1, and that's a y coordinate. So if it's positive 1/2, that's going to be tied to pi over 6. Okay, because pi over 6 has a y value of positive 1/2. All right, same, now we're talking about cosine. Cosine, remember, goes from 0 to pi. That's its restricted area on inverse. So it says in this restricted area for inverse, where would you have a positive cosine of 1/2? Well, it's got to be in quadrant 1 because cosine is not positive in quadrant 2. So it's going to be in here, and that's saying, okay, the x coordinate has to be a positive 1/2. Well, the x coordinate is a positive 1/2 at pi over 3. All right, so that's our alpha minus our beta. Those are our values. Okay, so let's put it into the formula. All right, tangent of alpha minus beta. Here it is, alpha minus beta. We're going to be using this guy down here. All right, so is equal to the tangent of your alpha minus the tangent of your beta divided by 1 plus the tangent of alpha times the tangent of beta. Okay, so equal, well, our alpha is pi over 6, so it's going to be tangent pi over 6 minus tangent pi over 3 over 1 plus tangent pi over 6 times the tangent of pi over 3. All right, so that's going to make up the denominator. All right, there's our entire formula. So now we're just going to substitute the values in, okay, and do the math. All right, if we do that, we're going to end up with equals. Okay, so tangent of pi over 6 is radical 3 over 3 minus the tangent of pi over 3, and according to your unit circle, that's simply radical 3. We're going to put that on top of a 1 since we're talking about fractions. Downstairs, you're going to have 1 plus the tangent of pi over 6, which is radical 3 over 3, and this is super easy because you got the 2 guys you need right upstairs, times the, times the tangent of pi over 3, and that's going to be radical 3 over 1. Okay, now we're just going to do the math. All right, so we have, unlike denominators here, so you know you're going to multiply the denominators together to get your new numerators. Your new numerators are going to be the cross product. So it's going to be 3 times negative, 3 times 1, radical 3 times 1 is radical 3, minus radical 3 times 3 is 3 radical 3. And we'll fix that in just a minute, okay? And then, where was it? Okay, that's the top. Then downstairs we're going to have 1 plus top times top over bottom times bottom. So radical 3 times itself is just going to give you 3. And then that's going to be over 3, which is 1. So we can simplify this even more. Radical 3 minus 3 radical 3 is minus 2 radical 3. Okay, over 3. Over 1 plus 3 over 3, well, that's equivalent to 1, right? So downstairs is totaling to 2. All right, now we know it's 2 over 1, so we're bringing them upstairs. And you're going to say negative 2 radical 3 over 3 times 1 over 2, because I've flipped him. Okay, and you can have these 2's cancel out, and you're going to be left with negative radical 3 over 3. Okay, so that's a tangent example, and that's the first full out tangent that we've done. Okay, so just remember, use your algebra clear up your denominators, and that one fully simplified to negative radical 3 over 3. Just remember, if you're talking inverses, you have to look at your restricted zones on the unit circle before you pull out your theta. Okay, I may make a couple of more. I'm going to stop now because I've got a conference call, and I might post a couple more. I want you guys to work on everything that you can. Do not be intimidated by those, some of those identities, but just use your algebra. Number 55 is a challenge, and I gave you a hint to try to think about how to set that up. Actually, I pretty much told you how to do it. But I want you to give those a shot, and remember, honors you do starred and everything else, and traditional you do red dots and highlighted only. And I will talk to you guys on the Teams meeting tomorrow when we meet. All right, have a great night. Bye.